Welcome back everyone, this is Dr. Gonstein and here we are for the RStudio tutorial for lecture number 2. Let's jump right in. So here's the data set, here's the code we need for analyzing our data set for statistical significance. So as I mentioned before, when we begin, if we do not already have the packages that we need to run the commands that we want to use, then we need to install them. But if you watched the last lecture, you should have already installed these. Okay, so I'm going to go ahead and start by importing my data. And then, like I mentioned in the last lecture, it's super important to just get a feel for your data. So let's go ahead and do that. I'm going to use the str, the structure command first. This will show me the structure of the data that I have. It's very similar to last lecture. We have the same variables from last time. All of them are numeric variables. So that means the values are just numbers. And they're read as numbers. Okay, and then, but we have one new variable from last time, and this is called job. And what we can see by looking here is that this job variable is a different kind of variable. It's not a number. It's a CHR, which stands for character. It's a character variable. That means its contents are words instead of, words or letters, I should say, instead of numbers. If we want, we can take a look at just the first couple of values for the data set using the head command, and we get a better feel for what we're looking at. So we have an extra variable this time. We have a 7th variable, job, and you can see that the contents of that variable are words. It looks like it shows what sector or what type of job each individual person has. Okay, we can use summary or my preferred option, describe, to get some descriptive statistics for the variables. So here we are. This gives us a nice table of the descriptive statistics. You'll see here something interesting. We have descriptive statistics for the variable job, but the job variable are a bunch of words. So there's a little asterisk here, and it kind of indicates to you that you should really disregard this information. This isn't real information. The job variable is just a bunch of words, so we don't have any quantitative information on it. Now, we might want to produce a like a frequency table for the manufacturer or the job variable. So let's just do that. That'll give us some interesting descriptive statistics for the job variable. When we can't really get anything interesting quantitatively using the describe command. So I'll just go ahead and produce a descriptive statistics table. I'm sorry, a frequency table for the job variable. And here we go. We can see the frequency in both absolute terms and in percentage terms for each of the different sectors that they might work in, and it even produces a nice graph. So there we go. Distributions of the job variable inside of the wages data set. So that's interesting. Okay. Now let's jump in with what we need to do today. The big thing that we need to know how to do is for this lecture is we want to do a comparison in the means of a variable between two different groups. And we want to see if, even if there's a numeric difference, is that difference statistically significant? So let's look at wages by education. I have a bunch of different values of education here. Okay, we can see that we can look at the distribution of the education variable. There's quite a number of different values for that education variable. So what we're going to do is we're going to generate a dummy variable, a binary variable, that equals 1 if they have a high school degree, and it equals 0 if they do not. So if they don't yet. So basically 1 if they fall above high school and 0 otherwise. So here you can learn how to generate a new variable, and in this case, generate a dummy variable. So let's look at this line of code here. What I want to do is I want to create a new variable. I want to call it high school. I want it to equal 1 if they have a high school degree and 0 otherwise. And I want to create this variable inside of the wages data set. So right now the wages data set has 7 variables. I want to create a new variable inside of that data set. So I'm going to do wages, the $sign, which says to create the variable inside of the wages data set, and I'm going to call it high, I'm going to call it this, high SC for high school. All right, it's going to be equals to, and I'm going to use a command if else. It's kind of a neat command. What it's going to do is it's going to evaluate, maybe I'll write a little note here, if else, okay, what's going to do is some condition, and then the value of the variable if it's true, and the value of your new variable if it's false. So you'll write some condition. If that condition is true, it will give, I should say, value of new variable if the condition is true. It's true, and then the value of the variable if the condition is false. Okay, so that's how this command works. So all right, if else. So if the education variable inside of the wages data set is greater than 12, you can see this greater than sign here. So if the education variable inside of the wages data set is greater than 12, that is, if the number of years of education is larger than 12, they have more than 12 years of education, then let this new variable, high SC, equal 1. If it is not true, let it equal 0. That's what that line of code is. Let's run it. We'll run it. You can see that the wages data set, it had 7 variables and now it has 8. We can click on it and get a feel for it. Just look at it. Move this over. We have a new variable. It's composed of zeros and ones. We can see that if the person has 12 or less years of education, it equals 0. Okay. If they have more than 12 years of education, it equals 1. Okay. So that looks good. It looks correct. Excellent. So now what we're going to do is we want to get a conditional mean. We want what is the average wages for people that have a high school education and what is the average wages for people that don't have a high school education. We'll use that command like we used last time, and here we have it. Those with a high school education have an average wage of 7.42 in this data set, and those without a high school education have an average wage of 4.89. Okay, but now the big question that we learned from this lecture is, okay, there is a numeric difference. 4.89 is numerically smaller than 7.42, but the question is it statistically significant? Or is it just spurious? Like, is this real about the populations that we're looking at? Well, let's ask the question. We're going to use a t-test. We're going to compare. We're going to do a mean t-test comparison of the wage variable between those that have a high school education and those that do not. So let's run it. So here we go. We're going to use a t.test command. And what that's going to do is it's going to take the first variable here, the wage variable that's inside of the wages data set. Okay, it's going to take this variable and it's going to compare the mean. It's going to compare the means between the two groups defined by the second variable. The second variable here is this high school dummy variable. It is inside of the wages data set. Okay, and this little squiggly line in R, it means on. And what this is basically saying is it's going to take the wage variable and it's going to compare the values for those with a high school education and those without a high school education. So the first variable is the variable where you're taking the averages of. The second variable is the variable that defines the group that you're using for those averages. So let's run this. All right, so this gives us the output of our t-test. You can see down here we have the mean in group 0, so that would be where high school equals 0, and the mean in group 1. So here's the average for those without a high school education. Here's the average for those with a high school education. We already saw that here, but it just reproduces it here. You can see what it is. So here you can see the command that we're doing, and then here are the results of the statistical test. And here's the p-value. The p-value is what we use to determine if it's statistically significant or not. You can see here this is a very small number. It has 13 zeros. or I should say it would be 12 zeros below the decimal point. That means you move this decimal point 13 places. This is tiny. It's well below all the standard thresholds. So what this is saying is that it is statistically significant at the 1% level that there is a difference between wages for those with a high school education and those without. Okay, so very quickly, just doing the same, but now with the manufacturing dummy. So we're just asking the question, let's just produce a table real quick. You get to see all the different values of the job variable. We just want to ask the question, is there a statistically significant difference between in incomes between those that work in manufacturing and those that work in other sectors? So we'll create a dummy variable that will equal 1 if they work in the manufacturing sector and 0 otherwise, using the same if-else command. I encourage you to pause the video and take your time and read through this, or as you're taking notes, read through this, make sure you understand it. I'm going to do that. Now I have 9 variables. All right, I have this manufacturing variable, and I'm just going to do the t-test as before, using the same command except with the manufacturer variable instead of the education variable. Just run this, and then here we go. We have the mean for those in manufacturing and the mean for those that are not. And we can see the p-value is 0.9247. That is well above any standard threshold, so this difference is not statistically significant. Because of that, we would conclude, or we would fail to conclude, that there is any difference in wages between those that work in manufacturing and those that do not. Okay, great. I look forward to seeing you in class. Have a great day.